Hello, in this video we are going to study about storage class. So you all know what a variable is. Variable is a named memory location, right? It is a location onto which you can store data. So that is what a variable is. So basically a variable is having two properties. The first one is called as type and the second is called as storage class. So we all know what a type is. It is nothing but the data type. That is, the type of the data that we store onto a variable is called as the data type. So that is the first property of the variable, right? So we all know what all different types of data types we have, right? Like integer, float, character, double, etc., right? So basically, data type is nothing but the type of the data that we store to the variable, and variable is a named memory location. So we are clear about that. Now we are going to the second property of the variable, and that is what we are going to discuss on this session, which is nothing but storage class. So a storage class basically it is concerned with three things, that is the scope, in default initial value and the lifetime of a variable. Scope is nothing but the scope. The scope means it is the availability of the variable. That is, in which all function the variable that you defined will be available determines the scope of a variable. Next is the default initial value. That is, actually when you create a variable, we assign a value onto it, right? Suppose if you do not assign a value, then that value will be known as the default initial value. That is, if you do not explicitly assign a value, the variable will be already having a default value within it, and that is what is called as the default initial value. And the next is called the lifetime of the variable. That means how long a variable can live or how long it can exist is called as the lifetime of a variable. So basically a storage class is concerned with the scope, that is on which all function the variable is available, and the default value is, suppose you do not give a value onto a variable, then what is the default value that it is contained, and the third is the lifetime of the variable, that is nothing but how long the variable can live in a program. So all these factors are what that is determined by the storage class, and there are basically four types of storage class, that is at automatic, external, static and register. So we are going to study in detail of each of this. So let's start with automatic variable. So before explaining this slide, let me explain you with the help of a sample program. So look here, as you all know, this is the basic structure of a C++ program. Here we are going to study about the automatic variable. Okay, so you all know how to declare a variable, right? Suppose you know the data. If you want to Okay, so this is basically the syntax of how you want to um, declare a variable, right? So that is, you have to name a variable. First of all, you have to give the data type of the variable, then followed by the name of the variable, right? This is the syntax of declaring a variable. So we all are familiar with this. So first of all, let us name the variable as A and the data type. So A is the name of the memory location, and data type will be telling what type of data that can be stored onto the memory location A. Suppose I am going to store integer values, I will be giving int, right? So in this case, A is a memory location onto which I can only store integer values, right? So these type of variables are called as automatic variables. Okay. So the other name of this variable is called as automatic variable or local variable. Okay. So you can either write it like this or you can write auto int A. Both are correct. Okay. So you can You can write it either this way or this way. We are familiar with this way, so it is better to write on that way. So I am removing it. Okay, so we are all familiar with this, right? So this type of variable is called as an automatic variable. It is otherwise called as a local variable. Let us see why it is called as a local variable. So you all know this is a function, right? Main is a default function on which a program on which the program statements are written, right? Okay. Now let us consider, suppose you are having another function in this. Okay, look here. See, inside main, I am creating variable a and assigning it value 10. Right, okay. Now I am trying to display the value of the variable a, which you have defined in function main inside the function display. Okay. So as you all know, if you write a function should have three parts. That is, the first part is function definition. It is there. And the next part is function call. Function call is always within the main function, right? So it is, I'm calling the function inside the main. This is called function call. And there is one more part, that is function prototyping. So that is always written above the int main. Okay, so this is called function prototyping. Prototyping. Okay. Okay, now look here. So what you have to understand here is there is a main function. In addition to that, you have another function called display function. So basically, there are two functions here, right? Now I am declaring the variable a inside the main function, okay, and I am trying to display the value of a inside the new function, that is the display function. Okay, let's see whether it works. You can see that it is giving an error. Can you see this? A was not declared in this scope. Did you see the word scope? That is what is called as the place where it is available, and that is called scope, right? It is defined within the main function, right? The scope of the variable a is only within the main function. You can access a only within main function, but you are trying to access it outside the scope of a, right? That is on the display function. That is why it is not available. Suppose, say for example, you are printing it here. See out. Okay. I'm commenting this. Now you can see the values displayed. Did you see this? Yeah. So what is the main reason for this? That is, it is called a local variable. That is, only it is available only to the function where you have defined it. That is, you have declared the variable inside the main function, right? So it is available only within the main function. But if you try to access it on another function, it gives an error. Because why? It is out of the scope. Its scope is only within the main function, and if you're trying to access it out of the scope, you cannot access it. So that is what is called as the scope of a variable. Since it is local only to the function it is defined or declared, it is called as a local variable. Hope that point is clear. Now let's go to the slide. Okay, you can see this. So it is telling, basically storage class tells you about three things. First is called the scope. Now you can understand scope is the function where it is defined. It is the function or the method or the module. All these are other terms of other synonyms of function. Okay, function is also called as module or block or whatever it is. Okay, so onto which function or onto which module you define a variable, it is only available there, and that is the scope of the automatic variable or the local variable. It is local only to that function. So that is the scope, and the default value is, suppose um, as you can see here, I am giving an explicit value 10, right? So suppose if I'm not giving a value also, it will print a value. Okay. So what is that value? And that is called as the default value. And this default value is called a random value. It can take any value. Okay. This is not necessary to have a particular value. It can take any values. That is why it is called as a random value. So if you want to change the random value, you have to explicitly assign a value onto the variable. So next is the lifetime. As you have seen it, its lifetime is only within that function or that method. Outside that method, the variable is not alive. So that is what is told in automatic variable or the local variable. And this is, I have already discussed. It can be written either like this or like this. Both the ways are correct. So this is about the automatic variable. Now we are going to the second type, and that is called the external or the global variable. Before discussing about the storage class parameters, let me explain this with an example. Now look here, we are going to study about global variable. Okay. I'm using the same function. Okay. Did you see this? Okay, global variable is always defined above the uh, main. Okay, so so uh, just like defining a normal variable, the syntax is like this. Okay, what is it? That is data type followed by the variable name is the syntax of the global variable. Okay, this is, and a global variable is always defined just above the main function. This is called global variable. So I'm going to name the variable as A, and I'm going to store integer values onto it. So I am giving the data type as int. Okay, right. Once I do this, what happens is it is creating a memory location A onto which I can store only integer values. Okay. Now let's see. I am giving the value 10. Did you see this? Okay. Now I am trying to display it inside the main function, that is A inside main function. Okay. So when it displays it, okay, now I'm trying to display the global variable inside the main function, and I'm also going to display it inside the display function. Okay. So this is clear, right? Okay. That is, I am trying to access a global variable inside both the functions. Okay. Let's see whether it works. Okay, you can see that it works on both the function. Did you see this? That is, the scope of a global variable is on the entire program. Okay, it is available throughout the program. You can call it on any of the module. It is not like the local variable. What was the difference between the local and the global variable? Local variable is available only within the function where it is defined. But in the case of global variable, it is not like that. It is available throughout the program. You can call it on any of the functions. Okay. So what is the scope of it? It is available throughout the program, and that is why it is called as a global variable. So let's go back to the slide. See, look here. The global variable, the scope is everywhere in the program. That is why it is called as global variable. Now coming to the default value, suppose if you are not giving an explicit value onto it, by default it will be taking the value 0. Okay, let us try it. See, if I'm not giving 10, I'm going to display it run. See, it is taking the value 0. Did you see that? So if I'm not giving a value also, it by default it will be having a value 0. So the default value of a global variable is 0. So that is what is told here. And the next thing is called the lifetime. That is, lifetime is until the end of the whole program, right? It can live anywhere in the program. So the lifetime is throughout the program. So that is what is called as a global variable and an external variable. Always for exam, some questions like this are asked. What is the difference between a local variable and a global variable? So if you understand this, you can explain it very properly. So coming to the next is, there is something called as an extern keyword. So everyone is familiar about keywords, right? What was a keyword? They are reserved words, right? We cannot use that word for any other purpose, right? So reserved words are words we cannot use it for any other purpose. Reserved for, we have studied some of it, right? For example, int, float, character, they are all reserved words. And just like that, there is another reserved word called extern. This is a reserved word. Let's see what is the use of it. So by definition, it tells the compiler that this variable is declared somewhere else. Okay, and it does not allocate storage for the variable. So this is the definition of extern. Let me explain you with the sample program. So look here. So I am just removing all these things. Okay. Okay. Back to our normal normal C++ program structure. So I'm going to write here. Look here. I am writing something like this. That is C out A, and I'm going to run this. Okay. What happens? It tells that A is not declared. What is the type of the A and what is A? It is not told anywhere in the program, right? Suppose, let's see, I am giving it here, int A is equal to 10. Will this thing work? Let's see. It is again giving the same error, right? A is not defined within the scope, which means what? As you all know, the compiler can read only this much, right? The compiler reads the statements in a sequential way, and it can only read up to the end of the main function, right? So whatever that is given after that, it is not read. So in this case, what you have to use is extern int A. Okay, suppose you are using like this. Let us run and see what happens. See, it gives the value 10. Did you see this? So what is happening is, when you write something like this and you are defining the variable A somewhere else in the program, actually you are giving an instruction, or actually you are telling the compiler that don't worry, the memory location A, it is defined somewhere else in the program. Okay, so you just go and execute it. It's what it is told. If you do not give an instruction like this, the compiler will not understand that the variable A is defined somewhere in the program, right? It cannot know. So it is for the compiler to know, we are giving an instruction like this, that is extern int A, which means compiler understand that integer A is defined somewhere in the program. It is what that is told to the compiler. So basically this is called as extern. So the function of extern is basically telling the compiler that a particular variable is defined somewhere else, or it is declared somewhere else in the program. So, and on doing that, it is not allocating the memory. Okay. So this is basically the instruction, right? At this point of time, a memory location is not created. The memory location is only created when this statement is executed. So that is what is told. So hope that is clear. Now let us go into the another type, that is called the static variable. Okay. So let's see. Okay. Static variable. So I am again undoing all this, and I'm going to write a function. Okay. I'm just writing a display function. Okay. Display now look here. Okay, see, look here. So this is uh, a normal program written with functions. So the function definition tells that whenever a function is called, it will make a variable a and assign it value 10, and it displays the value of the a. That is what is done here, right? So let us execute and see. Okay, did you see this? When you call the function, it goes here and execute the statement and print the value of a, right? Okay, now let us call the function again, display. So what happens is, you call it display 10, again the control comes back here, the next statement is again display, so you again go to the display function and print the value of a. So what will be the value? Let us run and see. See, it is 10 and 10, right? I'm giving a slash n so that you can understand the difference. Oh, sorry. Okay, now you can see, right? I've given a slash in to beautify the output. That is, you can see that for the first time when you're calling the display function, it is printing 10. And on the next time also, when you call the display function, it is executing the first statement and this then displaying the value inside the A, right? The 10 on 10. Okay, so now let us use static variable. This is a normal local variable, right? This is a normal local variable. Now let us use a static variable. How can you make a local variable to static is just by adding the keyword static in front of this local variable. Okay. When you do this, let us imagine what will be the output of this. Okay, let us run and see. I'm making a small change. Mm. Okay, before going to static. Okay, I have made a small change to the program. Okay, now look here. What is the value? Displaying, first display will initialize A to 10 and add 1 to A. So the new value of A is 11 and it is displaying 11, right? When you call the display function again also, the same procedure happens and it will be displaying 11. Now I am making this local variable to a static variable and I am trying to run the program and let's see what is the output. And if you observe, when you call display function for the first time, you are assigning A to 10 and 10 plus 1, 11 is moved to A and see out what 11, right? But when you call the display function for the second time, this is a static variable, which means the change that you have already made to the function is stored there. It is still there. So it is not taking the old value 10. Instead, it is taking the new value of the A. What was the new value of the A? It was 11. So you are adding 1 to the 11 and the new value of A is 12. So you are displaying what? 12. Did you say this? So the main idea of a static variable is uh, it uh, it remembers the change that you have made to it. That is the main use of a static variable. So if you are using a local variable, every time you call it, it will be using, or it just forgets what was happened to it before, right? But in the case of static variable, it is not like that. If you make a change to it once, then it will remember it throughout the program, and that's the main difference of a local and a static variable. Hope this is clear. So let me call the display function again and let us run and see. So on this display function, the a value that it was remembering was what? It was 12, right? 12 plus 1 is 13. So the new value that will be displaying will be 13. Let's run and see whether it is correct. Yeah, now look here. So each time when you call the function, it remembers the change that was made by the function call that happened before. So that is the function, or that is the purpose of using a static variable. So let us go and see what is the scope of it. So scope of it is nothing but it is local to where it is defined. Okay, and the default value means even if you do not give a value to the static variable explicitly, the value it takes is 0. And the lifetime is what? It is available throughout the program, right? It keeps on remembering it until you until you step out from the program. But this variable is available only within what? Only within the display function. That is why the scope is only within that function. Suppose you are trying to display the variable a inside the main function. Let's see what happens. It is giving an error, right? Because it is telling it is out of the scope. That is what is told here. This is local only to the function where it is defined. You cannot call it outside the function. That is why here it is told that the scope is local to the function or the block where it is defined. Default value, that is, if you do not give a value, by default it takes the value 0. And lifetime is it keeps on remembering everything or every changes that you made to it, right? And this memory is kept until the end of the entire program. So the lifetime is throughout the program. So that is called static variable. Now coming to the last type of the storage class, and that is called as a register variable. So before going to the register variable, you have to understand about the memory. That is, you have heard about CPU, right? What is a CPU? CPU is the place where all the processing is done, right? It is the brain of the computer. That is where all the working, the mathematical calculations, everything is done there, right? So and all the data that the CPU required for functioning is basically stored in main memory. Okay, so CPU is a processor on which data is processed, and these data are usually stored in main memory. Okay, so this is the basic concept. And here, when you look here, the CPU is having something called as register. That is, register is nothing but a memory inside the CPU. Okay, so imagine, let me ask you a question. Uh, if you are storing 10 here and you are storing, say for example, if you are storing a data here on the register and storing the same data on the main memory as well, which is more faster to access by the CPU? Obviously it is the data that is stored on the register, right? The register memory is within the CPU, so it is easy to access the data that is within the register than accessing it from the main memory, right? So which is more faster? If the data is within the register, the access time is less for the CPU, right? So if you want uh, something to be accessed at a faster rate, you have to store it where? Onto the register. Okay, so this is the basic concept. So basically there are many types of memories are there, but we are now only discussing about the main memory and the register memory. So all the data that the CPU wanted to process is stored in the main memory, and there is another memory called a register memory. It is a very small memory. Okay, when compared to main memory, it is a very small memory. You can store only small amount of data there. But if you want to access something at a very faster rate, it is better to store where? It is better to store on the register rather than storing it on the main memory, because access time is very less when than the access time of getting or fetching something from the main memory. Okay, hope that point is clear. Now going to the register variable. Okay, So look here, I will explain this with an example. So I'm deleting all this. Okay, a normal program. Okay, look here, int I. Look, for uh, for int I is equal to 0, I is less than 10, I plus plus. Okay, I'm liking a for loop. Okay, I will tell you what I'm going to do. Hmm. So, as you all know, this is a very simple for loop for printing numbers from 0 to 9, right? So, if I'm giving, okay, let me, now this is fine, right? Now it is printing numbers from 1 to 10. Let me run and see. Okay, now you can see that it is printing from numbers 1 to 10, right? So, this, when you see this, int I, okay, so let me initialize or declare int here. Now look here, this I that you have used in the for loop is a normal local variable, right? Usually these variables or local variables are stored inside the main memory, right? But in cases like for loop, this variable I is repeatedly called for 10 times, right? So you are accessing the memory repeatedly, right? So it is better to store the variable I inside the register than in the main memory, right? So why? Because the access time of fetching data from the register is much lesser than fetching the data from the main memory, right? So it is better to store it where onto the register, because loops, in case of loops, you are calling the variable repeatedly, so you are accessing it repeatedly and too continuously, right? So it is better to store it in register memory so that the access time is less, right? So you want to store the variable I onto which memory? Onto the register memory. So that you have to give what? Register here. Did you see that? In with You have to give the keyword register to the local variable. So this is telling the compiler or giving an instruction to the compiler. I suggest you that it is better you store the variable where? Onto the register memory. Okay, it is just an opinion or a suggestion that is given by the program to the compiler, because this is a variable that is frequently asked, um, frequently executed. So it is better to store it on which memory? Onto the register memory rather than storing it on main memory, right? But it is just an opinion. If the space is available in the register only, it will store, or the compiler will store the variable onto register memory. So this is a suggestion that the programmer make to the uh, compiler. Okay, if this is a or I is a variable that is frequently accessed, so I suggest you to store it in register memory rather than on main memory. This is just a suggestion. If the register memory is available only, it is allocated to the variable I. If not, it is not allocated. So basically, register variables are used for faster access. That is it. Usually, cases like a loop, variables that we use in loops are basically stored onto the registers. So, coming to the slide, so registers. So, a register variable is basically a suggestion that we give to the compiler to store the variable onto register rather than storing on the main memory, because you are using the variable repeatedly. Basically, we use this only in the case of loops where you execute the variable repeatedly. Now, coming to the scope, the scope means it is available only within the function that it is defined. That is, if you define it on main, then it is available only there, because it's a normal local variable like thing. And default value means if you do not give a value, it can take any value. Okay, that is, if you do not assign a value to the register variable, it can take any value. It is not necessary that it should be 0. It can take any value. That is called as a random value. Lifetime means till the end of the method, only till the end of the method. If you come out of the method, the life of the register variable is over. Okay. Next is, this is the syntax, that is on to the register, normal local variable. You're adding a keyword called register. This is just a suggestion that is given to the compiler. It is better to store it on the register memory because this is a repeatedly used variable. Okay. So this is about storage classes. Um, Thank you.